Welcome to this explainer. I am so thrilled to be your guide today. We're going to play detective and investigate some of the most fundamental mysteries of the universe. We're looking at the very building blocks of absolutely everything around us and, well, inside us too. We are talking about the evolution of the atomic model.
So, what does an atom actually look like? Just take a second and try to picture it in your head. It's tricky, right? Because we literally can't see them with the naked eye. For centuries, some of the most brilliant minds had to just imagine this invisible world. And the way they pictured it has dramatically shifted over time as they uncovered new clues.
Okay, let's dive into this. What exactly is an atomic model? Basically, it's just our best way to visually explain what an atom looks like and how its internal parts are arranged. Since we can't exactly snap a selfie of an atom, we rely entirely on these visual models to predict how all matter behaves. Here's our roadmap for today. First, what is an atomic model? Second, the indestructible solid sphere. Third, discovering the plum pudding. Fourth, the centralized nuclear model. Fifth, planetary shells and orbits. And finally, number 6, the modern quantum cloud.
Section 1. What is an atomic model? Understanding the basics. You know, science isn't just a static list of facts. It's a constant, iterative discovery. We're tracking 5 distinct eras here, starting with John Dalton's solid sphere all the way through to Erwin Schrödinger's quantum mechanical model. Every single scientist either built upon or completely shattered the ideas of the person who came right before them.
Section 2. The indestructible solid sphere. John Dalton's model.
So Dalton proposed what's often called the billiard ball model. His core idea was super simple, but honestly revolutionary for its time. He said matter is composed of atoms, and he firmly believed these atoms were totally indestructible. Compounds were just atoms of different elements combining chemically, but the individual atom itself, that was the absolute smallest thing in existence. You literally couldn't break it down any further.
And this brilliantly illustrates Dalton's vision. It acted just like a microscopic billiard ball, perfectly smooth, dense, and solid all the way through. For a really long time, this simple, elegant concept was exactly how the entire scientific world imagined the building blocks of reality.
Section 3. Discovering the plum pudding. J.J. Thomson's model.
But, well, science loves a good plot twist, doesn't it? J.J. Thomson completely shattered that indestructible rule. Through his famous cathode ray tube experiment, he discovered electrons, tiny, negatively charged subatomic particles. The atom wasn't a solid, unbreakable sphere anymore. It actually had smaller internal parts. This was a massive leap forward.
To explain this new discovery, Thomson created the plum pudding model. Picture negatively charged particles just swimming around in a positively charged sea. It genuinely resembles a traditional English plum pudding. Those negative electrons act like little pieces of plum stuck inside a big, spherical mass of positive dough.
Section 4. The centralized nuclear model. Ernest Rutherford's model.
So the crucial point is that Thomson's model eventually needed a major upgrade, and that happened when Ernest Rutherford conducted his legendary gold foil experiment. By firing alpha particles at a super thin sheet of gold and watching them deflect, Rutherford realized that the positive charges weren't spread out in a pudding-like sea at all. Actually, they were highly centralized in one single spot.
Rutherford proved that the atom actually has a tiny, incredibly dense, positively charged center. He called this the nucleus. The negative electrons didn't swim in a sea. Rather, they orbited around this tiny central nucleus, leaving mostly empty space everywhere else. Suddenly, our atom went from a solid, doughy pudding to a buzzing miniature solar system. It's crazy how much changed.
Section 5. Planetary shells and orbits. Niels Bohr's model.
Now, Rutherford's solar system idea was brilliant, for sure, but mathematically, kind of chaotic. Enter Niels Bohr. Bohr brought in some rigorous organization. In his model, electrons don't just fly around randomly. They travel in highly defined circular orbits. He locked them into fixed energy levels, or shells, which is incredibly similar to how planets steadily orbit our sun in specific lanes.
You can see those distinct concentric rings surrounding the central nucleus. By locking electrons into these fixed energy levels, that previously chaotic atomic world suddenly became orderly, predictable, and honestly, remarkably elegant.
Section 6. The modern quantum cloud. Erwin Schrödinger's model.
Now, what's really interesting about this transition is that just when we thought we had these neat, predictable rings, Erwin Schrödinger triggers a completely mind-bending shift. We move from Bohr's rigid planetary rings to Schrödinger's quantum mechanical model. We realized electrons aren't on fixed train tracks after all. Instead, they exist in fuzzy, unpredictable, cloud-like orbitals around the nucleus. This is a massive conceptual leap. We are no longer talking about exact locations, we're talking about probability. Where the cloud is completely dense and dark, the chance of finding an electron is very high. Where the cloud is less dense, well, the probability of finding that electron drops off. It's mysterious, it's mathematical, and it's the absolute foundation of how we understand atoms today.
Let's move to and see how this builds in the real world. It's time to take these mind-bending concepts and make them tactile. We are challenging you to build your own physical atomic model, but with a catch. You can only use recyclable materials. Think cardboard, toilet paper rolls, bottle caps, paper cups, whatever you have lying around. It's a fantastic way to get resourceful, visualize the invisible, and hey, help save the planet at the same time.
Okay, here is your exact game plan. Step 1, choose your absolute favorite model from our timeline. Step 2, dive deep. Research the scientist, the year, and the main idea. Step 3, make a neat, durable 3D model using those recyclables. Step 4, prep a clear infographic or visual guide to go with it. And finally, Step 5, confidently present your creation to the class. Explain your model and be ready to answer some questions.
So, I'm going to leave you with this thought. Which atomic model will you choose to build, and how will it show our evolving understanding of the universe? Every single piece of scrap cardboard you use is literally a physical testament to how human curiosity continually reshapes our reality. Embrace that inner scientist. Think, create, and inspire. Thank you so much for joining me on this explainer, and I absolutely cannot wait to see what you build.